Okay, I said that wrong at the end of the last video. This is actually our fourth video. And now we are moving down to look at distance and angle bisectors. So now we're not looking at perpendicular bisectors, we're looking at angle bisectors. And this is what an angle bisector looks like. It cuts an angle into two equal parts. We can tell that because there's a tick mark there that matches, an arc really, right there that matches the arc right there. So we know that PC is a bisector to angle APB. Okay, let's look at what an angle bisector theorem says. Let me get my phone so that you can see it clearly, which may or may not be cooperative. There we go. Angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Let's read that again. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. This is a little similar to what we were doing before, isn't it? Let's look at the diagram. If a point is on the bisector of an angle, we have point C on this bisector, we already know for sure that it's a bisector because it has cut these two angles evenly in half. If it is on the bisector, then it is equidistant from both sides of the bigger angle. So we could go ahead and say that AC is congruent to BC. And moving on to look at the converse says the opposite, of course, and it says if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. Okay, let's look at the bottom diagram. This is the bottom of page 301, by the way. If a point in the interior of an angle, and we're looking at point C, and yes, it is on the inside of angle APB. It's somewhere on the inside. If it is equidistant from the sides of the angle, then it is on the bisector of the angle. Well, we do already know that it is equidistant from the sides because this tick mark shows us that it is the same as this distance, that AC is the same as BC, so C is in fact equidistant from A and B. That means that C does in fact lie on the bisector of angle APB. That is going to lead us to more information. If PC, line PC, bisects APB, then we therefore know that we can do this and show that the two angles are congruent. So remember, it's important to know the theorem from its converse and to understand for tests when you use which one, and to understand for homework when you use each one. So make sure that you review that. All right, there's another thing that we needed to look at before we move on, and that is this. I'm going to turn my phone sideways. That is this little sentence or couple of sentences right here. Remember that the distance between a point and a line is the length of the perpendicular segment from that point to the line. So several lessons ago and 2 tests ago, we talked about how the shortest distance from a point to a line was perpendicular to the line. And I'm going to draw a little diagram here to remind you of that. It was kind of like a interesting little triangle, and we might have had A, B, C, and this is perpendicular, which it does not appear to be. But we said that this point's closest distance to line segment BC is going to be a line that's perpendicular, not a line that goes at an angle. If you look over here, that's what we're seeing. It's not closest to go straight out. It's whatever allows that to come into the outer side of the angle with a perpendicular angle, okay? So just an important little note, but let's review these really quickly. An angle bisector theorem. If a point is on the bisector of an angle, the point is on the bisector, then it is equidistant from the sides of the angle, equidistant from A to B. And here's the converse. If a point in the interior of an angle is equidistant from the sides of the angle, which C is, then it does happen to be on the bisector of the angle. And that allows us to say the angle APC right here is congruent to angle CPB right here. All right, make sure you're understanding these things as you go. If you are not, please take time to pause the videos and really get a handle on it. And stay tuned for the next video.